Okay, welcome back to the channel. I have a K7000 here that I have already taken out of the box because there was no way for me to take it out of the box on camera without showing the owner's information. I could have cut it off the box, I guess, but you couldn't open anything on the box except the top. So I went ahead and just opened it up, took it out and set it down. I have not taken it out and inspected it. I haven't done anything to it yet, so you guys can share in the knowledge with me. But this was sent to me because it was blowing the fuse. So it should be rather simple to figure out. This was in a Revolution X. So let's take it apart here and out of the bag and see what we can figure out. Alright. Well, I don't have the remote board. They forgot to send the remote board. Again. Fortunately, like I've mentioned before, the last time I had one of these that was missing the remote board, I have the type of remote board that's required. So I'll sleeve it in for testing, but this appears to be mostly original. Someone has changed out these two caps, but it looks like this one in here is original. These here definitely are original. These two are, so it's got a partial cap kit, but it's blowing the fuse, and it has the original white knob flyback, and it's cracked like every single one of them right across the top of the focus. And right across the top of the screen, you can see how it's cracked there. Maybe you can't. Ugh. So let's try and get a better shot of this here. There you go. It's cracked across there. It's cracked across there. So is it arcing and sparking? Is there any evidence of arcing and sparking to the frame? Oh yeah. Yep. If we look right in here, you can see that little magic right there. It looks like it's arcing out of the flyback right to the frame there and doing a little dance. A little burn mark on it. Blew away all of the dirt, and a little burn mark right there in the center, and little electrostatic lines. And yeah, I think we got a bad flyback, so we'll have to change that. And I'm sure it took out D13 or D14 in here along with R91 or R92 like it always does. And we'll have to do a full cap kit. It's only got a partial one, and otherwise, yeah, this should be a fairly routine repair. So let's get cracking here, shall we? The first thing I want to do is go get the correct remote board and show you the which one it needs to be. But let's turn it around here on the bottom. Wow! Someone's been doing some repair to this in the past because they've taken out D10 and they've put D10 on the bottom of the board where it's not supposed to be. So we'll have to fix that. At least they've jumpered over across R101 here, and they've just added nothing but a big solder plane to this. So somebody has done some repair to this in the past. Very interesting. It's got the capacitor across D18 here for the width. I've made a video about that. Some of these have this, some of them don't. Depends on if you have an image that's too wide or not wide enough. You have to put this capacitor on here across D18. So, but all right. Well, let's get all of my parts together. All the parts we're going to need. I have everything in stock. Cap kits, flybacks, voltage regulators, R91s, R92s, D13s, D14s. Got all that stuff, so let's do some troubleshooting and poking around and see what we can find. But for now I have to cut away here. I have to go take care of something. And when I do that, I'm going to grab the remote board. We'll show you what's supposed to be hooked up to this, and then we'll get cracking on this and see what we can find. Okay, so here is the remote board that's required for this type of connection. And I mentioned it before, but in case you're new to this, it can hook up, it's not keyed, so you can hook it up this way or this way. This is incorrect. Do not hook it up this way. Hook it up with the connector facing forward here front. This is how it has to hook up. Now it's a bit redundant. Let's see, horizontal position is the only one on here that needs to be there. Because if you look here, there's a vertical size, and there's also a vertical size. Then there is a black level, as you can see here, black level, and there's also brightness right there. There is vertical position. And, oh, I lied. Vertical position and horizontal position. These two pots here are missing, and they're on here. I'm sorry, I was thinking it was horizontal position only, but it's these two. So these two are a bit redundant, but these two have to be on here. Now, if you wanted to, you could get yourself a horizontal position and vertical position pot, install them on this board, and completely remove this. This doesn't need it at all. But if you try and run this without this hooked up, without these pots in the circuit, you're going to be hating life, because with vertical position not in the circuit, you very well could damage the vertical IC or who knows what else. So it's absolutely imperative, if you have a remote board, a system with a remote board, it has to be plugged in before you power it on, or you can damage the chassis for sure, almost guaranteed. So there's a couple of options here. This actually came out of a Revolution X that actually has this board. I talked to the owner here while I was away, and it's bolted into the side of the machine, and he just unhooked it and sent me the chassis. So I'm going to leave this installed. I'm going to actually take a zip tie and zip tie this to the corner for strain relief so it doesn't break the wires off, and he'll have to reinstall this when he gets it. But that being said, we'll go ahead and just take this and leave it off for now, because that's not supposed to be on there for the moment. Doesn't need it. And let's go ahead and do what I suggested there with the zip tie. Okay. There we go. So now that that's done, let's start some inspection here. For the moment here, I don't normally replace the flybacks unless they need replaced. But with the fact that this is the white knob flyback, which is prone to cracking and being bad more often than the black knob flyback, and the fact that it's cracked in two spots, we're going to go ahead and replace it anyway as a preventive. Even if it's not arcing and sparking, I'm going to replace it as a preventive measure, because the white knob flybacks are notorious for failing in a spectacular way. So let's do our normal inspection here. I don't see any broken pots, so that's good. Let's go ahead and just put them all to center. Okay. We got a smashed resistor, not uncommon. Otherwise, we got a wobbly transistor here. Yep, look at that. Broken pad. That's why we inspect. Broken pad. Nice and broken. So we're gonna have to fix that. That's why you always do a visual inspection before you start working, because you'll find stuff like that and it'll save you time on the back end. Okay. Any of these other pots broken? They don't appear to be, so that's good. Any missing components or pieces, except for the fuse, it looks like. But I have this guy right here. I keep a... dropped a zip tie there. I keep this guy on hand for situations like this. It's basically a 2 amp fuse. And you can clip these leads onto here, and if something's shorted, it'll pop that circuit breaker. Rather than go through, you know, fuse after fuse after fuse, you can put this on here, it'll pop the breaker. You can reset the breaker, and if something shorts, it just pops the breaker again. So yeah, that's much easier than going through fuse after fuse after fuse. This little board right here is a mod, an unfinished mod that Wells Gardner was going to use. They were going to use this mod on all these K7000s, and then they never actually ended up incorporating it. There's some wires here for P1, P2, P3 that would go to various points on the board, and they ended up not using this mod, and instead of just taking it off, they just left it on here. So if you ever see a 7000 like this with this mod board on here, you can take it off, throw it away, do whatever you want, leave it on. It doesn't matter. It doesn't actually need to be hooked up to anything. It's an unused mod. So I don't think it's documented as to what this was supposed to do, but it is documented that it was a abandoned mod, if you will. So I guess what we'll do here is we'll start testing our components and see why the fuse is blowing. Let's go to diode. Let's test our rectifier diodes. Okay. This one's got glue all over it. Okay, that one's good. 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 Okay, rectifier diodes are good. R103. This guy there. Any of the components that I'm testing here, if they were bad or shorted or being open out of circuit, can cause a blown fuse. So that's, I'm just gonna go through here and test all this stuff. Just keep that in mind. If all the stuff I'm testing is for the blowing fuse here. 3 ohms is perfect. At R104 should be 15 ohms. And it is 15 ohms. R96, R89, I always forget which one that is. 3.9K. And it is. R101 I think should be roughly anywhere between 4.5 and 6. It's a 6.5 k ohm resistor, but I think in circuit it's anywhere between 4.5 and 6.5. So if we test it in circuit, it's close to 4.5, 4.2. That's not out of the realm of normality. So that one's okay. R97 should be 1.8. No, I'm sorry, 270. This one here, R90, there's R96. I always get R96 confused with R89 because they're just close to each other. But R96 is the one that should be 1.8. Yes. And then R96, yeah, I'm sorry. R96 is this guy here. R98 is this one over here. And I get those confused because they're both supposed to be 1.8. So R96, 1.8. R98, 1.8. Yes, so all of our resistors are good. And we can move on to the HOT. Again, this guy right here. Diode mode. HOT is shorted. That also means our critical safety cap's going to read shorted. Yep. Come on. This must not have... See, yep, it's the single 4-post one. Okay. Not sure why that's not reading across there, but there we go. I wonder if it's our critical safety cap, because that should... See how this reads are shorted? You just diagonal this way and diagonal this way should read the same, but we're not. I wonder if our critical safety cap is open or shorted. This leg could be shorted, but we'll have to remove, if the HOT is shorted, your critical safety cap will read shorted as well, and vice versa. So you have to remove one of the two from the circuit to find out. What about D18? Is D18 good? D18's good. Our voltage regulator, this kind of regulator here, should be pins 1 and 4. We should read around 0.151, and it's shorted as well. Fantastic. What about D13 and D14? Well, they're okay. Yeah, R91 and R92, it should be 1.2 ohms. That's okay. And I think the other one's right here. Yep, so those survived. Okay, maybe our flyback did not. Maybe it did not crack and short or send voltage out. Maybe it's okay. So far we have a shorted voltage regulator and a shorted HOT and or critical safety cap. And let's see, was there anything else I wanted to check? We got R103 diodes, all of our resistors, HOT voltage regulator, D18, D13, D14, R91, R92. I think that's about all I want to test. Oh, C38, our width cap. If the width cap shorts out, it can take the fuse as well. So that's going to be, they change that? Yeah, it's here to here. We're just checking to make sure that it's not shorted. So if we go from this pad to this pad, it is not shorted. It's in the mega ohms and climbing. So we have to take out our voltage regulator and our HOT, and then we'll have to see if our critical safety cap still reads shorted in circuit, and see if our HOT reads shorted out of circuit. So let's move on here. Fairly common. Fairly common issues causing the breaker to go. Most of these solder joints look like garbage. This one looks like garbage. The critical safety cap joints were never reflowed. There's a big cold blob on this joint. There's a big cold blob on that joint. This whole area here is all just one big cold solder joint, especially right here. All of our horizontal position pins, center, left, and right, those are about to fall out. The C38 solder is no good, so we'll have to go through and do a full reflow as well. But first, let's get these shorted components out of here and get going on replacing them. This damn iron, every time I go to use it, it's in standby mode. Oh, come on, 500. Sorry. If I was any good at editing, I would just speed this up, but I'm not. Alright, that should be good enough here to get it started. Well, there we go. We're at 700 degrees. I usually run my iron about 750 Fahrenheit. Because the hotter it is, the less pressure you have to put on the pad, and the less time you have to hold it there. So I generally like to use a little bit of extra heat to eliminate the time spent on the pad and the amount of pressure you need to get the solder to flow. So there's two different types of voltage regulators that you can have in these. You can have these these wide STR 3130s, and you can have the other ones that are skinnier and taller. I think they're the STR 3132. I forget. I don't have them in front of me. But there's the wide one, and then there's the tall one. It doesn't matter which one you have. The easiest way to test, regardless of which one you have, if it's shorted or not, is you can actually go to the B plus resistor on the side, go to your ohm setting, and go across your B plus resistor, and you can see that it reads 1.8 ohms. So it's our voltage regulator is still, it's probably still touching a couple of the joints there, but it's shorted 1.7. Now, as I take this out of here, let's see, I need to grab, is it this one? Nope, that's the cord. Okay, as I take this out of here, What happened to my... There they are. Come on. All right. So as I take this out of there, now that it's out, we can go back to our resistor, and I bet you it reads our, what is it, 180, something like that, 200, 220. See, there you go, 180. So an easy way to tell if your voltage regulator is shorted, if you don't want to actually have to go to the regulator and test it, whether it's pins 1 and 4 or 3 and 4, depending on the type, you can just go across your B plus resistor. If it reads, 0 ohms, it's shorted. If it reads, in this case, 180 or 200 or 220, depending on 19-inch or 25-inch, then you know it's not good, or it's shorted, or however you want to phrase it. So that's the easiest way to test your voltage regulator. But we know it's shorted, and if we take it out of circuit and test it out of circuit, pins 1 and 4, 1.9 ohms. So 3130, say goodbye. In the garbage you go. Now let's take this HOT out of here. And let's go. I have a nice desoldering gun, but I mentioned before in a previous video it's broken, and I haven't gotten around to getting a replacement. So we just go with the braid. It works just as well. Sometimes maybe a bit better. And that should do it. Grab the tweezers and grab the nut on the back side of here. There we go. And now the HOT's out. So now the question is our critical safety cap still shorted? And I think it was this way. It is not. I wonder why it doesn't read across though. That's odd. It should read across. But anyway, we go to our pads for HOT and it's not shorted. So we go to our HOT and we just test it. So we have a shorted HOT and a shorted voltage regulator. And now that I think about it, I want to take this back out of the garbage, keep it up here with the rest of the stuff. All right. Wow, our video header pins are really bad as well. These hardly have any solder left on them. Yeah. Let's focus up. Yeah, that's pretty bad. Okay, so if we go through here and review, everything tested good. Our critical safety cap is not shorted with the HOT out, so that's good. Voltage regulator is shorted out of circuit and not in circuit. So I guess the next step here is to try and figure out what caused the HOT and the voltage regulator to get taken out. Now, was it the flyback? I don't know. I guess we'll go ahead and just replace it for good measure. I'm going to go ahead and turn on my desoldering gun just so we can try and use it. But if you look here, it's seen better days. I tried to epoxy it back together and it worked for about 5 minutes till it heated up the epoxy and just fell apart again. But I can, believe it or not, I can still use it. I just can't move it around. I can, heat it up, and I have to use the iron against the pad to get the solder to flow, and then I use this and it takes it right up. So I'll go ahead and turn it back on here. But yeah, that's what's wrong with it. It needs to be fixed, and that's why I don't really use it unless I have to. For the flyback, that's a lot of solder to take off of there, so I'm going to do all that. But okay, you hear that? I'm going to bang on this, and it stops. That's the desoldering gun as well. It's or the station. The station makes noise. The gun's broken. I need to just get a new one. But I guess while we're waiting here, let's fix this broken pad for the color transistor. And the easiest way to do this is we'll just create a bridge. Let's just create a bridge across here. Come on. There you go. We'll just create a bridge, a nice little bridge. Oh, bridge over broken traces. I will bridge you down. There you go. Off camera. There you go, off camera. There it is. Sorry about that. There you go. That should work just fine. We'll clean it up later, but yep. While we're at it, I guess we can go ahead and do some reflow on this neck board. That one. That one. Yeah, the desoldering station's also a bit slow to heat up. I'm not a fan of Hakko. I've used Hakko in the past, and they clog. It clogs every single time on me. I used it like 3 times and it clogged so bad the third time I couldn't unclog it. It would never heat up enough, so I just said forget it and threw it in the garbage. And I went with this Amazon special one, and it's far and above the Hakko. A lot of people swear by the Hakko, but my first experience with the Hakko was not good, so I got rid of it, never looked back, and don't regret it one bit. Okay, that should work for the neck board. Oh, no, I want to grab... I mean, there's not really any reason I'm doing this right now as opposed to later, because I have to do the cap kit anyway. So, there's no real reason. I'm just doing it now while I'm waiting for the desoldering station. It's still not at the temperature. It's still 4 more degrees to go. Alright, so here's how this works for how I use this desoldering station. I will heat up the pad with the iron, and I will use the gun to suck this stuff out of here, and it works really well. Let it heat up and flow, and just like that. It works really well. And once it's done, I take the cleaner thing here, put it in the tip, and clean it out and leave it in there. It's important to leave it in there because if it ever there's ever solder in the tip here and it congeals, this will help release it and get it unclogged when you go to heat it back up again. So I always leave it in there. But that's the story of my desoldering station. So yeah, with that, I do need to hit, it looks like just the tiniest little nudge on this one here. And it should come right out. what we're going to do is cut this little piece off of here. That little piece that the screw was screwed into, and then it should just come right out. Hot dog, it's that easy. Okay. So yeah, I just cut this little piece off of here that the screw was mounted in, and it makes it easier trying to get it out of here without having to lift up this heatsink. Alright. Yeah, I don't think this was arcing. If we look at the side, there's definitely no spot here where it was coming out of. Well, I take that back. I looked at it in the viewfinder and I could see this with the right angle. You can see that. It might have been coming out right here. There's also a little burn mark right here. Maybe a little pinhole there. So yeah, maybe I'd say it's very possible that this was shooting electricity out to the frame, and that's what took out the HOT and the voltage regulator. And like I thought, if we look on the side here, you can see the disturbance in the force. You can see the disturbance here in the dirt, where I think it was zapping here, and zzz, and I think that's what was going on there. But no big deal. We'll get this replaced. Let's take this out. Disconnect this, and that should be it. Yep. So we'll set this aside with those other parts up there. I'm going to eventually need this, though. We can cut that off because we need to reuse this for the new one, for our G2 wire. Okay, so the point, so now where we're at here is I need to install a new HOT, a new voltage regulator. It looks like someone has cap. I don't quite understand, because if we look here, someone's definitely done a cap kit, but it's been a long time. That's not the original cap that was in there, and neither is this one. But these two caps are. Like these two caps here, I would almost guarantee are originally these 470 volt, or I'm sorry, 16 volt 470s. I can almost guarantee those are original. But all the rest of them look like they've been replaced. So I don't know. I may change out this cap here, the 35 volt 2200, because the rest of these have absolutely been replaced. So I think that's what I'll do. Is the three bipolar caps here were not changed. I can tell that. These are definitely original. These are definitely original. So I'm going to change all those out, plus this one, because the rest of these have all been replaced. So I'm not going to do a full cap kit, because the rest of these have all been changed already. It's quite obvious. I'll change out the 3 bipolars, these two, and this one. And then the new flyback. And then we need to replace the HOT voltage regulator, do a full complete reflow, and touch up what needs touched up. Take D10 off the back, put it back on the front like it's supposed to be. And then I think it'll be time for testing. So I'm going to cut away in the interest of not having a 2-hour-long video. I'm going to cut away. When I come back, I'll have all the work done. HOT voltage regulator, caps, reflow, everything. And then we'll be ready to test it. And then we'll see if that fixed the problem or not. I'm always hesitant because I don't know, why would the HOT and the voltage regulator get taken out if indeed the flyback wasn't arcing. But we have a couple of issues here where it's quite obvious that it most likely was, along with this. So there's only one way to find out. We'll put the new flyback in and do all the rest of the work and come back, and we'll be ready to test it. I'll show it off in all of its glory, then we'll hook it up and test it and see what we get. So stand by one moment. Okay, just like that, we're all done. I got the flyback replaced, brand new one installed. The old one is right here in the box. I'm going to go back to the owner as evidence of being changed. We have all of the caps I wanted to get replaced have been replaced, and I verified all the other ones are replaced as well. So we have a full cap kit in. So here's all the old caps. Those are going to go with the owner as well. And then we have the bad HOT and voltage regulator. So yeah, and that's all back together, all cleaned up. All the joints have been reflowed, and a good cleaning. Probably could use a little bit better cleaning, but good enough just for a quick cleaning to test. I got all the places that need reflowed and retouched all touched up. All the video header pins, anything and everything else that needed touched up has been touched up and reflowed. And I was not able to get D10. I was not able to get D10 back on the other side of the board because the legs are too short, so it has to stay on the back side. I didn't really find anything suspect except the cracked joints on the video header pins. Everything else seemed to be pretty good, but I still hit all of the points that needed it. But otherwise, yeah, so let's go ahead and test the HOT and voltage regulator now that they've been replaced, just so you can see that they're operational. Well, I say operational, but I mean not shorted. So, new HOT, there you go. And then we can test our critical safety cap. Should read the same. There you go. Now, see, now we're reading correctly. Now we're reading diagonal this way and diagonal this way and diagonal this way. That's how it should be. It wasn't reading like that before, and after reflowing it, now it is. So I think we had a cold solder joint on that. So that fixed that problem. And then pins 1 and 4 on voltage regulator, 0.15 or 0.150, something like that. 1 and 4. What are you doing here? What are you doing to me? There you go. 0.15. Yeah, 0.15. Close enough. So I think we're good to go. Let's go ahead and get on a tube. Cross our fingers, and I have the missing remote board installed from my stock, and we'll see how it turns out. So I'm going to use my circuit breaker. My circuit breaker that I talked about earlier. If it works, we'll pop in a new fuse, and we'll call this one repaired. Quick and easy. So stay tuned for one moment. Alright, we're all hooked up. We got anode, neck, yoke, ground, video, power, and remote board. And I got my circuit breaker installed. So I normally don't like to hook up video, but I'm fairly confident that this is going to work. I just think our flyback was arcing to the frame and took out the HOT and the voltage regulator. So, yeah, I think we're ready to test this. Actually, you know what? I forgot to turn off the light like I always do. Alright, so now let's go ahead and get eyes on our circuit breaker. And let's turn on power. Oh, hang on a second. All right. 1, 2, 3. Hot dog. That's a great sound to hear. And there we have it. Obviously, it needs a way adjusted, but so we'll turn down black level on here. We'll turn down black level on here. And we'll turn down contrast. And normally the flyback is all the way down on the new ones, so I turned it up a little bit slightly. And what we want to do now is turn it up till we get our raster lines. That's no raster lines. Oh, they're slightly there. Oh, I had to focus. There you go. So now we turn it down until they just go away, which is roughly there. Now we can turn up our brightness and contrast. We'll start with brightness. And it needs to, that's all the way up. Oh, no, that's contrast all the way up, sorry. Let's turn contrast back down. Brightness up to roughly down until that goes away, roughly there. That's where brightness needs to stay. Focus. I'm sorry, contrast. Contrast we'll put there. Brightness needs to go back down slightly. We can kind of see. There we go. Okay. Focus again. Yeah, this is an old tired tube. That's about as good as that's going to get. There you have it. So let's... Outstanding. Let's do vertical size. We have vertical size. We have a full image there. We're way too wide. Holy cow. Horizontal position. Roughly there. Wow, that is way too wide. Yikes. See if we can bring that down a bit. Oh yeah. Both sides. Yep, nice. We got a black margin on that side. And let's go a little bit more. And we'll do H position again. Yes. So there's a black on there and a black right there. Perfectly square image. Hot dog. So there you go. All right. I'll let this run for a couple hours. And otherwise, consider it success. So we had a bad flyback, suspectedly, that took out the HOT and the voltage regulator, and it needed a couple of caps and a good reflow, and it's back in business. So there you have it. Quick and easy fix. Thanks for watching. Hopefully you learned something, and we will see you next time.